Hi everybody, today we are going to discuss how to find the derivative of a function. Alright, so let's start by talking about what a derivative is. So the derivative of a function, which we denote with this symbolism f prime of x, is another function that will tell you the slope of your original function at any point. So this is the formula to help us find the derivative of a function. Notice it is a limit. So this is something that we have been talking about in terms of finding the slope of the line. So here's just a quick recap of where that formula comes from. So if we have some function, I'll just call this f of x. If I want to find the slope of the line at point x, the slope of my function is going to be the same as the slope of my tangent line. And then this is at f of x. So I know that to find the slope of a line, I need 2 points. So I can use my slope formula. So let's say we pick some other point right here. And let's say that these 2 points are h units apart. So if that's x, this must be x plus h, which would make this f of x plus h. So I know that I could find the slope between these 2 points, and if you actually connect those 2 points like this, that slope is not too far off from the slope of our tangent line. However, you might notice that we can make this slope more accurate by picking a value that is closer to x. So if we can decrease this distance, this h value, if we can decrease the distance between our 2 points, we can get a much more accurate slope. So let's imagine we picked a value and then a value that is 0.0001 units to the right. The slope between those 2 points is going to be extremely close to the slope of our tangent line. So that's why we take the slope formula. So notice our slope formula, as you know, is y2 minus y1 over x2 minus x1. So we write that out. We get y2, which is this, minus y1 over x2, x plus h, minus x1, which is h, or which is x. So you'll notice that the x's cancel out, which is why we just have h in our denominator. So this is just the slope formula. But we notice that we don't just want the slope formula, we want the slope formula as this distance gets incredibly small, which we can use a limit for, the limit as h approaches 0. So essentially we're using slope formula as the distance between the 2 points gets incredibly small. So that's where this formula comes from, and this is what we are going to be using to find the derivative of our function. All right, so let's try this first example. They would like us to find the derivative of f of x. So we are going to use limit as h approaches 0 of f of x plus h minus f of x over h. So let's start by finding f of x plus h. We're just evaluating this function. So remember, if I asked you to find f of 3, you would go and you'd substitute x with 3. So I'm going to do the same thing. We're going to substitute x with x plus h. So 3 times x plus h squared minus 2 times x plus h. F of x plus h is this. And then we're going to subtract f of x, which is 3x squared minus 2x. So 3x squared minus 2x is f of x. And then we're going to say all of that over h. So now all I'm going to do is I'm going to multiply everything out and combine like terms in my numerator to see if we can evaluate this limit. So if I multiply out this binomial and distribute in the 3, we're left with 3x squared plus 6xh, because 2xh times 3, plus 3h squared minus 2x minus 2h minus 3x squared plus 2x. That's why I'm really careful about grouping f of x, because we have to distribute that negative to the entire function. Okay, now let's combine like terms within our numerator. So you'll notice that the x squared terms cancel out as well as the x terms. So what we have left is 6xh plus 3h squared minus 2h all over h. So I can't evaluate this limit using direct substitution yet because our function or our expression would become undefined. So I'm going to divide out a common factor of h. I notice that's a common factor, so I can divide it out. 6x plus 3h minus 2. So remember, the behavior as h approaches 0 of this will be the same as this. So here we can evaluate this using direct substitution. I'm going to replace my h with a 0, and what I have left is 6x minus 2. So it turns out that 6x minus 2 is our derivative. So I'm going to say f prime of x is 6x minus 2. So this new function will tell us the slope of our original function for any x value. So the input is going to be an x value. The output of our derivative function is the slope of our original function. Okay, go ahead and pause the video and give this one a try. Please, be careful and take your time with x cubed. You do need to multiply out those binomials. Okay. So here's all the work. Here you can see is where I multiplied out x plus h cubed. I also have a quick little recap over here of binomial expansion using Pascal's triangle. So make sure you understand how to form Pascal's triangle. And remember, you can use these values as the coefficients. Since it's x plus h cubed, we use row 3 for that. So that's just a little recap there. It might save you some time. So multiply everything out, combine like terms, and then to evaluate the limit, we need to divide out a common factor of h. Here's what we have left. We can evaluate this limit using direct substitution. When I substitute h equals 0, this turns to 0, and this turns to 0, and I'm left with 3x squared plus 2, and that is our derivative. All right, so now we're going to try an example where we're going to use the derivative. So they asked us to find f prime for f of x equals square root of x. Then we're going to use that derivative to find the slope of our function at these 2 points. So that's the whole purpose of a derivative. So let's start by finding that derivative using our limit formula. So limit as h approaches 0 of f of x plus h, so square root of x plus h, minus f of x, which is just square root of x, all over h. So to evaluate this limit, we're going to use one of the techniques we've talked about earlier in this chapter, which is to rationalize. So here we can rationalize our numerator by multiplying by the conjugate, square root of x plus h plus square root of x. So I'm going to multiply in my numerator and denominator by that conjugate. Okay, so in my denominator, we're going to leave it factored out like this. I'm not going to distribute in that h. So in our numerator, I have this times this, which just becomes x plus h. And then this will cancel out with this, and then what I have left is minus x. So if I simplify my numerator, you'll notice that my x terms cancel out. And then for me to evaluate this limit, I can divide out a common factor of h. And then I should be able to use direct substitution. So I'm left with 1 over square root of x plus h plus square root of x. So if I do direct substitution, I have 1 over square root of x plus square root of x, which is 1 over 2 times the square root of x. So f prime of x is 1 over 2 times the square root of x. So this is our derivative. And remember, the output of the derivative function is the slope of our original function at any point. So I need to find the slope of our line at this point first. So I'm just going to find f prime of 1. I'm going to substitute x equals 1 into my derivative function, and I get 1/2. And then to find the slope of our original function at this point, I'm just going to find f prime of 4. So if I substitute 4 right here, I get 1 over 2 times 2, which is 1/4. So this is how we can use the derivative to help us find the slope of our original function at any x value. All right, last example. Go ahead and pause the video and give this one a try. All right, so here, same idea. We have f of x plus h minus f of x all over h. To evaluate this limit, we're going to need to rationalize. So I multiply the numerator and denominator by our conjugate. So here is the multiplied out numerator, which if you combine like terms, we're left with just h. Here we can divide out a common factor of h, allowing us to evaluate this limit using direct substitution. This gives us a derivative of 1 over 2 times the square root of x minus 1. We can use this derivative to find the slope of our original function when x equals 2, which becomes 1/2, and when x equals 10, which becomes 1 over 2 times 3, which is 1/6. All right, that is all for today's lesson. Thank you so much for watching.